One last video cast in Chapter 4 on solution stoichiometry. 3 more sample problems. Once again, our steps in solving solution stoichiometry problems are: number 1, write the balanced chemical equation. Number 2, convert to moles, generally using the molarity triangle. Sometimes you will use the periodic table to go from grams to moles, or from moles to grams, and sometimes you use moles to particles using Avogadro's number, very rarely. Third step, mole to mole ratio, and then fourth step, convert to units, usually using the molarity triangle, sometimes using the periodic table. So have this handy if you don't have this outlined somewhere. Pause right now and write these steps down, 1, 2, 3, 4, because we're going to follow them in these three sample problems. Step number 1, practice exercise 4.16. A sample of iron ore is dissolved in acid, and the iron is converted to Fe+2. The sample is titrated with 47.20 milliliters of a 0.0224 molar permanganate solution. The oxidation reduction reaction that occurs in the titration is as follows. And it looks like kind of a complex reaction, but the thing that you really need to pick out of there is that here's my iron +2, and then here's my permanganate stuff that's being added. So what's my ratio between those two things? Well, this got a 1 in front of it and a 5 in front of it. It doesn't really matter how complex the reaction looks. What you really got to be able to do is pick out the species of interest and then be able to say, oh yeah, 1 to 5 ratio. So how many moles of MnO4 were added to the solution, which is actually step 2 of any solution stoichiometry problem. First, write the balanced chemical equation, done for us. Second, convert to moles. So moles are equal to molarity times liters. Here's our molarity triangle. The molarity, we're told, is 0.0224 molar. And we're told that it has 47.2 milliliters, so 0.0472 liters. Multiply those two critters together, and it turns out that we get 1.057 times 10 to the negative third moles of the MnO4 minus that were added. That's letter A. Letter B, how many moles of Fe+2 were in the sample? Well, now it's like we're in step 3 of a solution stoichiometry problem, because we take our 1.057 times 10 to the negative third moles of MnO4 minus, and we're going to relate the MnO4 minus to the Fe+2. And if you look on the balanced chemical equation, there's a 5 in front of the Fe+2. There's a 1 in front of the MnO4. So we'll take that number times 5, and it turns out that it's 5.3 times 10 to the negative third moles of Fe+2 that were added. So we're just using the balanced ratio from the balanced chemical reaction of 5 to 1. Third question, how many grams of iron were in the sample? Well, we were told from the last problem, or figured in the last problem, there were 5.3 times 10 to the negative third moles of Fe+2 in the sample. So how many grams of iron were in it? Well, even though it says +2 right up here, you remember that just means that it lost 2 electrons, so we can still look at how many grams there are in a mole of Fe, even though it's missing 2 electrons. It doesn't make any difference to the mass, because electrons don't weigh very much compared to the protons and neutrons of Fe. And Fe on the periodic table has an atomic mass of 55.85. So we'll use that number, 55.85 grams in 1 mole. And 5.3 times 10 to the negative third times about 56 is 0.2952 grams of iron were in the sample. And then lastly, it says if the sample had a mass of 0.8890 grams, what is the percentage of iron in there? Well, remember, percent is always part divided by whole, and our part is 0.2952 grams divided by the whole thing, which is 0.8890 grams times 100%. Divide those, multiply by 100%, and it turns out it's about 33.21%. So there's our percent yield, and notice, or our percent of mass that was in the sample. Notice this is a solution stoichiometry problem actually broken into like 4 steps. And if you follow each one of the steps, they could have asked the last question right away, but since it's kind of a complex equation, people get confused once in a while when you see those. Maybe it's more confusing to do it in 4 steps, who knows. Next exercise, sample exercise 4.17. question. One commercial method of peeling potatoes is to soak the potatoes in a solution of NaOH. Once you've done that, you remove them and spray off the peel. Well, the concentration of the NaOH is normally in a range of 3 to 6 molar. The NaOH is analyzed periodically, and in one analysis, 45.7 milliliters of 0.5 molar H2SO4 is required to neutralize a 20 milliliter sample. What's the concentration of the NaOH? Hey, here's a true commercial use of NaOH. Step number 1, write your balanced chemical reaction. NaOH plus H2SO4. Everybody likes potatoes. And you end up with some Na2SO4 plus some HOH. To balance this critter, you need a 2 here and you'll need a 2 in front of the NaOH. Don't forget that the 2 showed up here because this is a -2 charge and Na is a +1 charge. And you carry the SO4 across because it's all part of a polyatomic ion. So that's step number 1. Step number 2 is to convert to moles. Molarity is equal to moles divided by liters. If we want to know moles, remember, and just take our molarity times our liters. So the moles of the thing that we know here are 45.7 milliliters of 0.5 molar H2SO4. So 0.5 molar times 0.0457 liters. Remember, the trick way to move from milliliters to liters is 1, 2, 3 to the left. And then once we've done that, then we could actually move on to the next step if we wanted to, because this is step 2 where we convert to moles. Next step is to find the mole to mole ratio and then convert to our asked for units. So we're told that this is the number of moles in our H2SO4, but what we want to know is how many moles there are in our NaOH, because if we find that, we can stick it back into the molarity triangle and find out the concentration of our NaOH. So put H2SO4 in a position where it's going to cancel. Notice there's a 1 in front of that, 2 in front of the NaOH. Multiply these two critters together. Multiplying these two together, we end up with 4.56 times 10 to the -2 moles of NaOH. Now it's asking us for the concentration of this, so to find concentration, molarity is equal to moles divided by liters, so we'll take our moles of NaOH and divide it by our total liters, which I believe is 20 milliliters, so 123.020 liters. Divide those two animals, and I believe it turns out to be about 2.28 molar solution. 2.28 molar solution for our NaOH used to peel the potatoes. They said it should be between 3 and 6 molar, so that means they got to add a little more NaOH to be some good potato peelers. All right, last problem of the video cast, practice exercise 14 or 4.17. In this one it says, what is the molarity of an NaOH solution if 48 milliliters is needed to neutralize 35 milliliters of 0.144 NaOH? Classic titration solution stoichiometry problem where we're going to follow all 4 steps. Balanced equation, convert to moles using the molarity triangle, mole to mole ratio, convert to units. So step number 1, balanced chemical equation. NaOH plus H2SO4, and we end up with some Na2SO4 and some HOH. We need a 2 here and a 2 here, and we should have a balanced chemical equation. That's step number 1. Step number 2, use the molarity triangle. Molarity is equal to moles divided by liters to get our number of moles. Moles would be equal to our molarity, which is 0.144 times our liters, 0.035 liters. Multiply those two guys together and you'd have your moles of H2SO4 Put a multiply sign, put a line, put H2SO4 in a position where it's going to cancel. And then the thing you want to know is what is the molarity of the NaOH. So put NaOH as your new set of units. So now we're on to step number 3. We converted to moles. I just didn't push the buttons on the calculator for that yet. Now we're doing the mole-to-mole ratio from what we know, H2SO4, to what we want to know, NaOH. And the ratio here is 1 to 2. So 1 goes here, 2 goes there. When I multiply those guys together, I end up with 0.01008 moles of the NaOH. And it asks what is the molarity, or what is the concentration. So molarity is equal to moles divided by liters. Here's my moles. Now divide that by my number of liters. And it told me that there were 48 milliliters needed. So divide by 0.048 liters. Divide those out, and you end up with 0.21 molar solution. Good luck with your solution stoic problems.